Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to NPTEL course on groundwater hydrology and management. This is week 12, lecture 4. In the last lecture, we looked at one particular remote sensing data that can be used for understanding long-term, basically 20 years of groundwater, approximately groundwater depletion rates, and across the world throughout the planet. And at monthly intervals. So you see a lot of ands I'm using for this data because it has been a very useful data for a lot of regions. However, especially in India, there are some limitations on using it. So that is where we could look at beyond the data and merging the data to have a single cohesive data for groundwater management, because not all data can be taken from remote sensing, as we've seen the resolutions and the size. Similarly, you cannot take all from the observation data, which has its own limitations. Measuring the deep groundwater aquifers is very expensive. You're not going to put a tape inside and measure. Think about 300 meters, 400 meters groundwater touching. How do you put a reel? You don't have that reel which goes in, touches the water and comes out. Remember, we talked about how to measure groundwater levels. Okay, so here, this part of the lecture series, we are looking at how do you collect these data and set it up in a fine scale model and then run for your analysis, etc. Okay, so we have looked at the key data that from the water balance, what data is available. And then we've looked at different vendors for the data, as WRIS has picked CWC, IMD, CGWB, and other data centers. We've also looked at certain specific data that can be used for local scale, like state agencies, SWID, PWD from Tamil Nadu, etc. And we have also looked at multiple stakeholder data from NGOs and publications. So the NGO and publication data is not peer reviewed, as I mentioned, and they're not going to be liable for any authoritative finding that comes out, which means it is not a government record. And also when you cite it and use it in your research, you can use it, but potentially someone may say it is not a government data, it is not a government record. Okay, so for that aspect, it is also important to find what government reports have. So initially we have talked about CGWB as a government level, groundwater monitoring level agency. In today's lecture, we will be looking at their reports. What do they do with the data? There can be so much done by collecting the data and running some analysis. So we can see how they prepare these reports and make it available for the public. Since this is the only agency in India that looks at groundwater, CGWB, the central agency I'm saying, they do have a mandate to give annual reports. Sometimes the annual reports are not on the exact year and there is some delay. However, they do get the data and produce these kind of beautiful reports. It's a very in-depth report. It's a lot of data, a lot of techniques, methods, analysis done in the report, and we can go through the basics. So in today's lecture, I will showcase you how you could access these reports and what does it mean? What does it mean, the differences? Okay, so when you see a report like this, it will be saying Faridabad or Delhi, depending on where the report is released. So the place is not as important, but be careful. There are state central groundwater board offices that do reports also. So you have an annual report for entire India, and you have reports for West Bengal, Gujarat, Rajasthan alone. And both of them may be similar in terms of the content or may not be because of the in-depth state level agencies that may go. For example, this report would take all the water levels in Gujarat and make a trend analysis. Is the groundwater going up or low? Okay. Whereas the Central Groundwater Board Gujarat report, just the Gujarat report, may have extra data focusing on Gujarat, because that cannot be done in the Central Indian report because it will be too much big a volume, right? So they'll give you the initial findings, and those who are interested can go to the state level agencies and collect the data and report. So it is a report which tells about the different methods on estimation of groundwater resources, including the groundwater level methods, the GEC methods, other methods that are widely used across India for understanding the groundwater levels. And fluctuations. It also gives you the borehole litholog data that they have collected. We have gone through in class what is a borehole, how do you collect data in a litholog, etc. But what CGWB does is they also take it to their labs. They have a chemical lab with CPCW, CPCB, Central Pollution Control Board, and they have other private agencies where they could test these values and get a record. Okay, so because they have monitoring wells and they have exploration wells where they dig and assess the aquifer thickness, permeability, hydraulic conductivity, etc. by taking samples and taking it to the labs. So this report can serve as a hydraulic conductivity database for your regions. Remember, I used freeze and cherry book for the entire planet. If you know the rock, if you know the soil type, you can assess the hydraulic conductivity. But it is a big range. There's a big range that freeze and cherry has given. Now, this Central Groundwater Board data would be anywhere in between that range. So now you're fine-tuning your range so that you could address these differences in the in your reports and research. Okay. Good. So then what you do is you have groundwater level analysis. As I said, the key data that they collect on long term is the groundwater level. The other data may be one-time collection, the exploration wells, rainfall is collected from IMD. So what CGWB collects is samples which are sent to lab, and some properties are measured, including the water quality. But most important, the frequency in which groundwater level is collected is the highest in CGWB. The other data, compared to other data that CGWB collects. So what do they do with the groundwater level? They analyze the annual recharge for a basin or for India or even for a state district boundaries. How much recharge has happened? So you know the pre-monsoon level, groundwater level before the monsoon, and then after the monsoon, it rises up. Okay. So that is being captured by the post-monsoon water levels. So that is why they have seasonal groundwater levels. Pre-monsoon, post-monsoon, winter, and you have somewhere around spring, you have one water level. Okay, so kind of seasonal, and the season is enough to capture the recharge, because pre-monsoon to post-monsoon is the recharge, and from post-monsoon, the water levels deplete to pre-monsoon. So if you have 2 years, let's say 2012 and 2013, 2012 pre-monsoon, which is August, is taken as a low level. And then from there, you have a high level in, pre-monsoon we can take as May. Okay, pre-monsoon May 2012. And then August is the post-monsoon 2012. So now I can estimate the recharge. But the discharge, how the groundwater goes down, I have to go to the next year, next May. Okay, so from August 2012 to May 2013, how the water level comes down is the discharge. That is why you don't follow a calendar year for hydrological estimates. you only follow a hydrological calendar or water calendar. A water calendar is when you have rainfall, the day one starts. And then 365 days later, you have all the seasons coming in. Okay. So normally in countries like Western countries, they have a water calendar, and the water calendar starts in the month of the monsoon. Okay. So for example, if it starts in June in Maharashtra, we call June 1 as the calendar start, or June 6 when the rainfall comes as a calendar start. So now you know how to estimate annual recharge, which they do for you, and the annual discharge is done. And the same is done for every block. Okay? The smallest they do is block, the largest they do is for India. So if you do the block level estimation and you find that your recharge is more than the discharge, then you are positive, net groundwater positive. However, your discharge, if it is lower than your recharge, then you are net groundwater negative. Okay. So then we saw the percentages. If you're using 0 to 50%, you're safe, and those kind of things we saw. 70-90% is, which is still net groundwater positive, is critical. The over exploitation above 100 is over exploitation. That is the concern, and most regions in India are going through that phase because of higher pumping for groundwater for agriculture and higher pumping because of technological interface. They also do budgets on how many wells are there, exploration, what are the maintenance costs for that, and also what are the explorations they do, what are the science they bring. All these research has a budget. So they discuss the budget and office details, which means where do you go and collect data. For example, these books may have historic data also, which is reference. Inside the book, you will not find it. Because of the volume, as I said, you don't find all the data. So what you do in those kind of scenarios is you go to the office, you approach the office and see if they give the data for you. And the point is you need to liaise with them. You discuss with them by email, or you go in person and say, I would like to have this data. What do you think about sharing the data with us? And what is the sensitivities on the data, where I could use, where I cannot use these data. For example, we don't know what the sensitives are, and it is better not to ask them why is it sensitive. Just ask if the data can be shared, and then use the data. Okay? Not all data is available for public or academic reasons. So those office details are very important, where you can go ask them about the different procedures. The scientists are very good. We have different scientist levels in CGWB. I remember when I was a student also, I used to communicate with the CGWB office in Chennai, in Besanagar, and they were very, very helpful. They would teach the concept, etc. Because they are also always in research, and they're happy to see people who like to work on groundwater as a student. So coming back, all the other data that is available is water quality data from these groundwater reports, which are also very, very handy when it comes to understanding the groundwater change. So the groundwater reports are kept in this kind of an archive. We will go through this, and you could see that 2005, 2006, there was a report 6, 7, 7, 8, 8, 9, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So all the reports are here except the 2021. Okay, maybe the COVID issues, they were working on it, and the data was not collected, sampled, etc., because of the travels restrictions. But however, we have all the data for the last 15 so years. And we'll be looking at some of the reports on what they have in this coming session. So let me share the screen of how to find this link. You can go to the link, but I always teach you how to Google it, because sometimes the link changes. Okay, I cannot give you a link and expect it to be there for the next 5-10 years, right? So I would support more on teaching you how to find it, so that you can also check it later. Yeah. So now my new tab is visible, and what I put is CGWB groundwater report, and I click OK. So I've typed CGWB groundwater report in Google. So that is what I type in Google, and you get all these links. The first link is what is necessary. So I'll just click annual report, Central Groundwater Board. And I'll also show you that you can say, let's say West Bengal. See, you can have a region report. Okay, I'll just click on this to show you that report also. Just one example, then we'll go back to the national board. Okay. So while this is downloading, it started to download. You could see that groundwater yearbook. They call it as a yearbook, and it is 2019-2020 West Bengal. Okay, WB stand for West Bengal, and AN is Andaman Nicobar Islands. So what is this? Like every region has a regional office, and that office is mandated to monitor groundwater in certain locations. So this West Bengal office has to monitor West Bengal plus Andaman Nicobar Islands. Maybe the size of the state also plays a role, right? Because Maharashtra is bigger, much bigger than West Bengal size, and I would assume that West Bengal, office is as big as Maharashtra, so they would put two states in one office. Okay, so you could see here that the yearbook is done, and then the Eastern region headquarters, as I said, the whole headquarters is in Delhi, whereas the region headquarters is in Kolkata. All these you have a foreword telling what it is, and then a small budget of the groundwater water budget. So the net annual rainfall, net sown area, cropping, recharge, stage of development is only 50%. So this is the water budget. Okay, how much water total recharge is 43.82 billion cubic meter. Net groundwater availability is 39.64 billion cubic meter, and the use is only 19.94 billion cubic meter, which is approximately 50%, 50.29. Okay, so somewhere you see that the availability and the draft is still, you get only 50% use in West Bengal. So the critical blocks, semi-critical blocks, etc. As a state, maybe 50% is small, but when you go to certain locations, there's more groundwater use. That is what this data is showing. And then all the other for Andaman Nicobar also. But again, as I said, let's focus on one national report, and then you would kind of look at the state report for data as and when you need it. Okay, so when you type it, the first thing that comes is CGWB annual reports. I'll take the latest one, which is the 2019-2020 data. And you could see that this report was done in 2021. So 1 year it takes for them to release the data. Okay, so they collect data for 2019-2020, but it takes 1 year to make this report, and then they release it. Okay, so under supervision, who did it? Those scientists, as I said, the scientists starting from C to G. So scientist G is kind of a high level, So, but we have here the young scientists who are working on it. Very, very helpful they will be if you go and approach them. So the executive summary and average abstract would be very helpful to look at these kind of reports, because you can get through all of it in one go. The first thing I would like to stop here is the budget. What do they use the budget for? How much in lakh rupees? In lakhs. Okay, so this is around lakhs. Okay, so 275 lakhs. So that is approximately 275 crores. Okay, so you have 275 crores spent on that year. And then revised estimate, expenditure. So you see how much budget was given, how much final grant was given, and how much was used. Okay. And then non-plan, all these things, building officers, recoveries. NHP is the National Hydrology Plan, which is they're mapping the aquifers and size and all those kind of things. So you could see how the budgets are broken up and how they are used. And then some mandates about CGWB, what are their objectives, you can find everything. So as I said, please go through these reports before you approach the Central Groundwater Board, because don't go to them and say, give me data for this location. They'll just say, go to WRIS website, because now everything is online. I remember when I was a student, as I said, there was no WRIS website. So the data sometimes was available on the Central Groundwater Board, but the location was not available. It will be like district, this is the well. So how do you map it? So that was a difficulty, and CGWB helped in those kind of locations. But now everything is shared, right? So be careful, be knowledgeable, do your homework before you go there, and ask for the right data. Organization setup, how the hierarchy is set up, all these things. As I said, there are scientists and then officers, division managers, etc., which is again not needed for us. And here is the regional officers. So always go to the regional office. It may not be called as directly CGWB Chandigarh. It is Northwestern Region Chandigarh CGWB. Okay, and what are they responsible for? So there is a Northwestern region in Chandigarh responsible for Punjab, Haryana, and Chandigarh. And then there is a Northwestern Himalayan region, Jammu, Kashmir, and Ladakh. The Chennai, which one I used to go, they would take care of Tamil Nadu and Puducherry. Pondicherry is small, so Puducherry and Tamil Nadu would have been mixed together. And then let's look at Nagpur goes with Maharashtra, and Maharashtra includes Pune and Dadra and Nagar Haveli. So you could see only some states are just by themselves. Okay, Odisha, for example, and Uttarakhand, those kind of things. Okay, and then there are engineering divisions. You can go and see where the engineering divisions are kept. State unit officers, etc. Okay. Okay, so they also give a forward on what are the managing, what are they applying the data, what are the manpower used for. For example, the National Aquifer Mapping Plan is a big plan that have been started and going through with a lot of budget, where they map the aquifer boundaries in India. So when you go to this report, you can find those kind of methodologies, how they do. So for example, when you go to WRIS website, you see the boundaries, but you don't see the method in which the data was collected. And this is the report which gives you that information. Okay, so for example, the flow chart is given, data gap analysis, the flow for aquifer maps and management plans are given. So when they get the aquifer, any type of requirement, research or monitoring requirement, they would go through these flow charts to first assess what is the data gap analysis, generate data, integration of data, preparation of aquifer maps. And then each aquifer, once it's mapped, has a management plan. So that has been made. And then presentation at regional offices, review by members, review by central level expert committees where, for example, IIT professors would sit and go through, and then finalization of aquifer maps and management plans. So it's a very scientifically well-focused flowchart which tells where is the gap, what data do we have to generate or bring, and then they do this mapping. Okay, so this is how much area has been mapped. All these different plans and data on these will be there. So these are the groundwater exploration, as I said. You see the big driller that comes in. It drills inside, takes samples at each and every depth that they want. And then it says like 160 meters below groundwater level in Wardha district, Maharashtra, yield and discharge of 465.6 liters per minute. That's a lot of water. So what they do is they measure the yield. Also, they measure the samples, take the samples on what type of hydraulic conductivity is there, those kind of things. Okay, high discharge rocks, etc. And then how many rigs they did, how many samples they collected. This rig samples, this deep drilling samples, how many did they go, and all these small abbreviations are given normally in the text. So if you go through the text or here, it is direct rotatory, dual rotatory, down the hole methods. Every single method is actually captured, and then they show where the total number of drills have been done. So for example, you would see 6 drills are done in Gujarat for sure, because there is more data that is needed. More depletion is going on, so they would like to see more data to understand why the depletion is going on. And then where they have the pumps to measure the yield, discharge. And here is the state-wise well constructed in 2019, 2020. As I said, they do have wells, but maybe it's not enough. All these wells, most of them are open wells or dug wells, okay? And the piezometers which go in the deep aquifers are very limited. For example, as here, Gujarat, you don't see any piezometers. And we know that Gujarat is facing a lot of groundwater issues. Punjab, for example, has deep groundwater issues, but there's no piezometers, right? So here's where they do put some budgets for the next year to have more wells in for monitoring. Then in the district-wise, how many wells have been constructed, those kind of things. Okay, so I'll skip the wells. Now let's go to the data. Yes. So here's where they have some high-yielding aquifers. They've identified, drilled, discharged, and they also say if it is a EW or open well. Okay. So these are very interesting to understand why they have these selection. And is it an exploratory well or observation well? For example, all these wells that you see here that they plan to put are either EW, which is exploratory, only one time they'll take a sample and take the yield, or they have the open well. Open well is always they monitor. So you see that there's a lot of exploration wells they want to put down rather than open wells and piezometers. I would say that could be more adapted towards getting more data, but let's see. Okay, so here they have also measured some resistivity on seeing how much resistance it is there for drilling and all these things. They've constructed a 3D map, which we have seen in class, fence diagram, where they have the lithologs, the bore logs, and then they use a software to connect the lithology, and only 2 layers they have identified, clay and sand. So as I said, the exploratory wells are taken. And these EW wells, you can see EW there in the bracket, are then linked to each other through lithography, stratigraphy techniques. And then this kind of fence diagrams are made to show how the aquifer thickness are. So again, all these have been discussed in class. So please go ahead and look at it. And then they also talk about the water qualities analyzed, and then how much of them have heavy metals, those kind of things. Now we get into the data, region-wise water sample analysis, the region. So here they break India into regions, central region, northern region, southern region, southeast region, those kind of things. And all these region, what is included in the region is already given at the top in the book. Okay, so some more data is collected on evapotranspiration, rainfall. You can see annual rainfall is there, and then distribution of actual rainfall 2019, which is basically taken from IMD records because it is government, and then water supply schemes, etc., etc. So now we come to the groundwater monitoring. Number of wells in different ranges between August, okay, number of stations, and what is the depth of the well. Okay, for example, the total wells are around 15,000. And then how much of them are 0 to 2 meters below the ground, those kind of different statistics they grade. This is the important map, which I would like to show, the 4 maps, the 4 seasons that they collect, right? So depth to water level pre-monsoon, depth to water level peak of monsoon, and then depth to water level post-monsoon. So sometimes May, August, October, I would say that is 4 months, and then depth to water level January. The pre-monsoon and post-monsoon depends on the monsoon calendar, and also depends on the need for data. So here you see, where would you see the least water? You see the least water in the pre-monsoon season. If you look closely, you could see all of them are red or yellow, which means the depth from the top to the water level is at least 5 to 10. Yellows is 5 to 10 meters and red is greater than 40 meters. Okay, so this is the pre-monsoon. Let's put a calendar to this for Maharashtra. This could be the May month. And then you have August. August is the peak of the monsoon season because June, the monsoon starts. It picks up in July and August would be the peak. So you could see July, August peak has influenced the good rainfall on the Western Ghat region. So the water level is only 2 meters depth. So here initially it was 5 to 10 meters, but now the water recharge has helped the water level to bring up. However, this region is getting not much help because the monsoon doesn't help in that particular month, August. Then we have the post-monsoon season where some rainfall does go up north and you'd see more green color happening here. Green color means the depth to the water level is 2 to 5 meters, which is almost safe. And then in January, after the monsoon is done, the post-monsoon period is gone. Now the Rabi season is there, where crops are grown using the groundwater. You see, again, the blocks are turning into yellow and then red eventually. So the progression is yellow is kind of still safe, but then from yellow to pink and red is really, really concerning. And that is where these water levels are going ahead. Okay, so from here, they've done all these recharge estimates, a lot of data on mapping. Some particular exploitation studies are given in the book. As I said, you can take the Maharashtra book, you'll get a full record of all the studies. In the annual groundwater book, you'll only take some snippets, some studies from here and there. Okay, so here they have done some artificial recharge structures, AR, which we also looked at in class. They've taken photographs of some artificial recharge structures along Maharashtra, percolation ponds, subsurface barrier for arresting the flow. Check dams have been constructed and pre-post leaky dams. Everything that we discussed in class mostly are shown here. Okay, and the gates of the dams, how they release the water, etc. And then some events that they did for water, groundwater news and authority will be showcased. So most importantly, the data is here. The trends are analyzed at a national level. Okay, and you could also see that you have this Harket Kopani, which they want to double the farmers' income by having more grain per water drop. Okay, so which is kind of helping the farmers work with available water in a very conservative way. Okay, so you could see that they have been having meetings a lot on this, some discussions, books released, all these things are there. So from here, you can go to some more sophisticated books and research outcomes. Okay, so then meetings and where they talk, a lot of these scientists give talks to public, NGOs and other activities. All these are captured. Again, it does have a lot, but my point is, more importantly, the data and where to access the data is given. Okay, so the reports are very exhaustive. One class, I assume, is not enough, but I hope you could go through it and build some knowledge on it. It's not technical. The technical terms are already discussed in class with us. What you see here is very applied sense of these research that we did. With this, I will stop today's class. Thank you.